Hello there, and welcome to A Sleepy Scientist, your peaceful little hideaway at the edge of the cosmos, where curiosity can unwind and science gently lulls you towards sleep. Before we set off on tonight's celestial adventure, I'd really love to know, where are you tuning in from tonight and what time is it for you right now? Drop your answer in the comments below. It always amazes me to see how many of us, quietly drifting together, come from every corner of the world. And if you find yourself enjoying tonight's journey, maybe give this video a soft thumbs up, or even subscribe to the channel. That way you won't miss our next stroll through the stars, and it helps more sleepy minds discover our quiet little nook. Now tonight's tale is a special one, how galaxies, those vast, shimmering cities of stars, rise from nothing but darkness and dust. My hope is it's just soothing enough to help you drift off. But if you end up too fascinated to sleep, at least you'll have something to ponder over your morning coffee. So for now, find a comfortable spot. Let your shoulders relax. Take a slow, deep breath. We're about to float through 13.8 billion years of cosmic history. No need to hurry. The stars will be there whenever you're ready. Let's begin. Picture this. 13.8 billion years ago, the universe wasn't just small, it was impossibly compact, more cramped than a windowless studio apartment, hotter than the core of any star, and denser than a physicist's planner at Nobel Prize time. Then, in a moment that stretches our understanding, it all began. Contrary to what the name suggests, the Big Bang wasn't an explosion in space, but rather a rapid, graceful ballooning of space itself, expanding in every direction faster than light, like blowing up a cosmic balloon with a leaf blower set to max. There weren't bits and pieces flying through emptiness. Space was the bits and pieces, creating itself as it grew. In those very first brief microseconds, the universe was a wild, churning soup of fundamental particles. Quarks bounced around with gluons, photons zipped about like over-caffeinated toddlers, and gravity, the ever-patient sculptor, began quietly taking notes. It was chaos, blindingly hot and deeply uncomfortable. Definitely not a place for stargazing or roasting marshmallows. But within that early pandemonium was incredible potential. Hydrogen and helium, the simplest, lightest elements, began to form, snapping into place like cosmic Lego from the charged chaos. These atoms would go on to build everything: stars, planets, people, pet lizards, and of course, galaxies. About 380,000 years after the Big Bang, a blink really, in cosmic terms, something beautiful happened. The universe cooled just enough for atoms to capture electrons and form the first neutral atoms. Suddenly, light, which had been ricocheting around like a firefly trapped in a jar, was free to travel. This moment, known as recombination, created the cosmic microwave background, a soft afterglow of the Big Bang that still hums quietly through the universe today. If your eyes could see microwaves, the whole sky would glow with the light of that ancient fire. But despite that faint, omnipresent glow, there were no stars yet. No galaxies, not even close. The universe at this stage was a dark, expanding cloud of gas and possibility. If you could have drifted through it, you'd see nothing but subtle ripples, tiny irregularities in an otherwise smooth sea of matter. These ripples were everything, the faintest whispers of quantum fluctuations from the earliest moments, stretched across the cosmos by inflation. Some areas were just a hint denser than others, almost imperceptibly so. But gravity noticed, and gravity never forgets. Over time, those slightly denser pockets of hydrogen and helium started to pull in more material, gently gathering themselves together, like dew forming on an invisible web. These clumps, the seeds of future galaxies, were utterly invisible, even if eyes had existed to see them. But already they were setting the stage for all the cosmic drama to come. It's strange to think of the universe as quiet, but in a sense, this era was. There was no starlight, no galaxies twinkling in the darkness, just the gentle, almost inaudible murmur of matter accumulating. It was a time of calm before the storm, a long cosmic inhale before the universe finally exhaled starlight. And even now, with all our telescopes and equations, we're still working out exactly how it all unfolded. How did those minuscule fluctuations blossom into the grand spirals and clusters we see today? Why did some regions become bustling hubs of stars while others remained empty voids? The answers are scattered across the universe, written in every glowing nebula and ancient star cluster. We just have to keep listening. So the universe continued to grow. Dark matter, the invisible scaffolding of reality, began to tug and shape the forming structure. Hydrogen was drawn into filaments. Gravity whispered, and the cosmos listened. Soon the first stars would ignite, and the darkness would begin to end. But not yet. The stage was only just being set. The universe was no longer just expanding, it was becoming. The stars hadn't arrived, the galaxies still slept, and for a few 100 million years, the universe remained cloaked in what we now call the cosmic dark ages. Despite the dramatic name, there were no knights or castles, no dragons, unless you count the ones made of plasma. This was darkness in its purest form, a universe full of matter, but not yet light. After the Big Bang's dazzling opening act and the soft glow of the cosmic microwave background, everything settled into a hush. Neutral hydrogen gas filled space like a vast invisible fog. There were no stars to pierce it, no galaxies twinkling in the distance. The universe had gone dim, not for lack of energy, but because it hadn't learned how to turn the lights on. Imagine floating through this era, an infinite, expanding sea of cool hydrogen and helium, with the occasional electron drifting by like a lazy jellyfish. Gravity was gently tugging on the gas, slowly forming clouds, but everything moved at a glacial pace. Time didn't matter. There were no clocks, no days, no sunrises, just the patient, gradual gathering of mass. And yet something extraordinary was brewing beneath the silence. The groundwork for everything we know was being laid. During inflation, the rapid expansion right after the Big Bang, tiny quantum fluctuations were stretched across space. These little ripples weren't much to look at, but over time, gravity took notice. Where matter was just a touch denser, it began to draw itself in. Over hundreds of millions of years, these ripples grew into tendrils and knots, the beginnings of what we now call the cosmic web. Think of the universe as a three-dimensional spider web, strung together by filaments of dark matter and gas. These filaments became the nurseries where galaxies would eventually form, pulled into place by gravity's persistent hand. In between, there were vast voids, immense, lonely stretches where almost no stars would ever shine. At the heart of it all was a silent partner, dark matter. It doesn't glow, reflect, or interact with light at all, which makes it both hard to study and a bit of a wallflower at cosmic parties. But dark matter was crucial. Its gravitational pull shaped the universe's scaffolding, guiding ordinary matter, hydrogen and helium gas, into place, like the hidden framework beneath a painting. Without dark matter, the universe might have stayed a foggy, featureless cloud forever. If you're still awake, and if you are, you have my respect. You might be wondering, why did it take so long for the first stars to appear? Well, building a star isn't as simple as tossing gas into a blender and flipping the on switch. Hydrogen had to fall into dense enough pockets for gravity to take over, compressing it until the temperature soared to millions of degrees. Only then could fusion begin, the nuclear dance that lights up a star. But the early universe wasn't in any hurry. It let gravity work at its own pace, coaxing gas into denser and denser clouds. Slowly, patiently, these clouds collapsed under their own weight. Somewhere in one of those dense knots, the first spark would ignite, a single point of light in an endless ocean of darkness. When that happened, everything would change. But for now, during this long, silent interlude, the universe was still gathering its breath. Like an orchestra quietly tuning before the first note, all the elements were in place, but the music had yet to begin. No galaxies, no stars, just a rising sense of anticipation, a promise that something beautiful was on its way. And maybe that's the most comforting thing about this time. Even in the deepest darkness, the universe was never still. Beneath the silence, it was dreaming, organizing, becoming ready. The light was coming. And then, at last, it happened. Somewhere, deep inside a collapsing cloud of hydrogen and helium, gravity tightened its grip. At the center of this invisible swirl, pressure soared and temperatures rocketed into the millions of degrees. Atoms were pressed so close together that their very nature began to change. In that instant, almost certainly unnoticed, with zero fanfare, a star was born. The first light since the Big Bang flickered to life. But these weren't ordinary stars, at least not by today's standards. Astronomers call them population 3 stars, and they were unlike anything we see now. Enormous, unstable, and blazing hot. They formed in the purest conditions the universe has ever known. No heavy elements, no carbon, oxygen, or iron, just hydrogen, helium, and a sprinkle of lithium, all leftovers from the Big Bang itself. This meant the stars burned much hotter and lived much shorter, more tumultuous lives than the ones we're familiar with. Some may have been hundreds of times more massive than our sun, living fast and dying young, either collapsing into black holes or erupting in titanic supernovae. If you somehow found yourself floating nearby, though let's be honest, you'd be toast in a heartbeat, you'd see these first stars setting their surroundings aglow, like bonfires in a pitch-black cosmic forest. One by one, their light pierced the ancient hydrogen fog that had blanketed the universe since the beginning. Slowly, bit by bit, the darkness began to lift. This era is known as cosmic reionization. It sounds like something out of a comic book, maybe a villain's plan to take over the universe with a giant ray gun, but in reality, it was a peaceful, if dramatic, process. The ultraviolet light from those newborn stars began to strip electrons from the hydrogen atoms around them, ionizing the gas and making the universe transparent again. Imagine someone slowly opening the shutters of a cosmic greenhouse, letting the light pour in for the first time in ages. From our vantage point, billions of years later, we can't see these first stars directly. They were too brief, too distant, and their light too faint, but their fingerprints are everywhere. They transformed the universe from cold and dark to warm and glowing. They seeded the cosmos with the first heavy elements, the building blocks of everything more complicated than hydrogen, including you, me, and maybe the cup of tea you're sipping right now. In a way, these stars were the universe's first artists, sketching the outlines of galaxies on the blank canvas of space. But galaxies themselves still hadn't formed. Not quite. These early stars tended to be scattered in small clusters, pulled together by gravity, but not yet forming the grand, swirling cities of stars we see in the modern sky. Think of them as villages, proto-galaxies, experimenting with structure and cohesion. Yet, the ingredients were coming together. As these massive, short-lived stars ended their lives in violent supernovae, they blasted heavier elements out into the surrounding gas clouds. Those enriched clouds cooled more efficiently, collapsed faster, and formed stars with greater ease. The next generation of stars, population 2, began to appear. A bit smaller, a bit more stable, and already more familiar. And so the great cosmic cycle began. Gravity pulls in gas. Stars are born. They shine. They die. And their enriched contents scatter, allowing even more stars to form. Each generation builds on the ashes of the last, layering complexity like cosmic sediment. You might be wondering, how do we know all this happened if we've never actually seen those ancient first stars? The answer is hidden in the patterns of light. ghostly fingerprints left on the cosmic window pane. By studying the oldest galaxies, the chemical signatures in ancient stars, and the faint glow of the cosmic microwave background, astronomers can piece together the universe's childhood in astonishing detail. It's a bit like reconstructing the history of a forest by examining its oldest trees, its soil, and the way the wind blows through the leaves. The clues are subtle, but they're there. And recently, we've started to catch actual glimpses. With powerful telescopes like the James Webb Space Telescope, we're finally able to see some of the earliest galaxies taking shape. Small, chaotic, glowing clumps of stars from just a few 100 million years after the Big Bang. We're peering into the nursery where the first light bloomed. It's humbling, really. These stars lived and died before our solar system was even a glimmer in the cosmic eye. Their light has traveled across billions of years, past colliding galaxies, roaming black holes, and the growing Milky Way, until it landed softly on the mirror of a telescope pointed at the night sky. And now it rests in your mind, in the quiet of your evening, as you drift towards sleep. The universe, once cold and dark, had lit its first lanterns. The night had ended, and the age of galaxies was about to begin. The universe was glowing now, not brilliantly, more like the faintest blush of dawn on a chilly morning. The stars had arrived. Their light unraveled the fog and warmed the silence, but they were scattered, isolated, flickering across the dark like distant campfires. No cities yet, no roads, just lonely pockets of light suspended in the void. But gravity had different plans. Those scattered stars weren't just drifting aimlessly. They were being pulled together by invisible threads. Everywhere you'd look, or could look, if you had eyes that could see ultraviolet light and the patience of a cosmic being, small clumps of stars were gradually converging, gravity gently threading them into larger, more complex structures. The villages were becoming towns. The towns would become cities. And these cities, these proto-galaxies, were the universe's first drafts of what we now call galaxies. It wasn't neat or orderly. There were no blueprints, no cosmic architects laying out spiral arms with rulers. It was messy. Clumps collided, merged, tore each other apart, and merged again. The early universe was a rough neighborhood. Gas clouds crashed into each other, stars were flung from one group into another, and some early galaxies grew quickly, gobbling up their neighbors. Others got stranded, left in lonely corners of space like wallflowers at the cosmic dance. At this stage, galaxies didn't look like the elegant spirals or massive ellipticals we see in telescope images. They were irregular, chaotic, unrefined, more like space blobs than the symmetrical beauties you might imagine. And yet, even in their chaos, they were growing. Slowly, their shapes began to stabilize, nudged by gravity and shaped by their environment. Much of this early architecture was influenced by a structure on an even larger scale, the cosmic web. Picture it as a vast, three-dimensional lace of matter woven across the universe. Dense knots, where filaments of dark matter intersected, became the hubs, the regions where galaxies would cluster like seeds in rich soil. Long tendrils stretched between them, pulling galaxies along invisible rails of gravity. Between these threads were vast voids, silent and empty, where few galaxies ever formed. It's in the dense intersections of the cosmic web that proto-galaxies had the most to gain, and sometimes the most to fear. When you concentrate a lot of gas and gravity in one place, things get dramatic. Galaxies crashed into one another, each collision a slow-motion dance that could take hundreds of millions of years. These weren't violent, explosive crashes. Stars are so far apart that most never touch, but their gravitational fields tangled, twisting galaxies into strange shapes. Tidal forces pulled streams of stars, like cosmic taffy, trailing behind their original homes. Gas clouds collided and compressed, sparking new waves of star formation, what astronomers call starbursts. So, amid all the chaos, new stars were born, new clusters formed, and over time, what was once a shapeless clump began to look a little more familiar. What determined the final shape of a galaxy? That's still one of those delicious cosmic mysteries we're working to solve, but we do know a few things. Galaxies that manage to stay relatively undisturbed, with just the right amount of spin and not too many dramatic encounters, could flatten into those elegant spirals, like our own Milky Way. Others, buffeted by collisions or born in more crowded neighborhoods, became ellipticals, round, dense collections of older stars. And some never quite settled down at all, remaining lopsided and patchy. We call those irregular galaxies, and honestly, you can't help but root for their chaotic charm. But even in their irregularity, galaxies had become something completely new in the universe. They were star forges. Inside, gravity and gas came together to ignite creation. Stars were born, lived out their brilliant lives, and died, scattering their ashes, carbon, oxygen, iron, into the interstellar medium, enriching the galaxy for the next round. Over billions of years, this recycling of stardust would build up planets, moons, atmospheres, and at least once so far, a small blue world where someone would one day whisper these stories into a microphone. It's easy to forget, looking up at the stars, just how long galaxies have been shaping themselves. The stars you see today are often second, third, or even fourth generation, made from the remains of countless ancestors. Galaxies are like family albums of the universe, each star a page, each cloud of gas a new chapter waiting to be written. And as galaxies grew, they began to form communities, clusters, groups, superclusters. Just as stars gather into galaxies, galaxies themselves are rarely solitary. They orbit one another, influence one another, and sometimes, gracefully and over eons, fall into each other's arms. Our own Milky Way lives in such a neighborhood, a little gathering called the local group, where it shares space with the Andromeda Galaxy, the Triangulum Galaxy, and dozens of smaller companions. But let's not get ahead of ourselves. For now, the universe had crossed another threshold. It was no longer just a sea of gas and light. It had structure. It had neighborhoods. The stars had found homes, and the cosmos had begun to organize its brilliance. By this time, the universe was anything but empty. Galaxies had formed, some shy and compact, others sprawling and dramatic. Stars spun in enormous orbits. Gas clouds shimmered with the light of newborn suns. The darkness hadn't vanished, but it had retreated, like a cosmic curtain lifting to reveal the grand stage of creation. And on that stage, galaxies began to find their form. Galaxies aren't uniform. They come in all shapes and sizes, much like snowflakes, if snowflakes weighed a few 100 billion suns. Some spin gracefully, like cosmic pinwheels. Others are squat and round, like celestial dumplings. Some, bless them, still look like someone tried to draw a galaxy from memory while riding a roller coaster. So how do these shapes arise? Why are some galaxies spirals, some ellipticals, and some just, well, oddballs? The answer, as always in astronomy, comes down to time, gravity, and a hefty dose of cosmic patience. Let's start with the spirals, the show-offs of the galaxy world. Spiral galaxies are among the most beautiful structures in the universe. They're the ones you see on posters as desktop wallpapers and in science documentaries where violins play in the background. With their graceful, swirling arms and bright, luminous centers, they look like hurricanes frozen in space. The Milky Way, our own galactic home, is one such spiral. We live tucked into one of its arms, a tiny speck in a vast, rotating city. Spiral galaxies tend to be rich in gas and dust, the prime ingredients for star formation. That's why they sparkle with so many young, bright stars, lighting up their arms like festive strings of fairy lights. The structure of a spiral galaxy is all about motion. When a galaxy has a decent amount of angular momentum, that is, when its gas and stars are rotating in a somewhat orderly way, it naturally flattens into a disk. Over time, density waves ripple through this disk, compressing gas and sparking star formation as they go. That's how spiral arms appear. Not as solid, unchanging structures, but as patterns moving through the galaxy, like traffic jams in space. Stars move in and out of them, but the arms themselves persist. Of course, not all galaxies manage to be so elegant. Enter the elliptical galaxies. Older, rounder, and generally a bit more relaxed. These galaxies don't bother with spiral arms. Instead, they're shaped more like spheres or stretched out footballs, giant collections of stars, usually older and redder, with little gas left to form new ones. If spiral galaxies are bustling cities, ellipticals are quiet retirement communities, stable, peaceful, and not big on change. Ellipticals most likely form through galactic mergers. When two spiral galaxies crash into each other, especially if they're roughly the same size, their graceful order is disrupted. Stars are flung into random orbits, gas is either used up or blown away, and what's left settles into a big, shapeless mass. It's dramatic, chaotic, and oddly productive, like smashing two snow globes together and letting the flakes settle where they may. Then there are the irregular galaxies. These are the nonconformists, the wild cards. Some are young galaxies that simply haven't had time to settle into a recognizable shape. Others are older galaxies that got a little too close to a bigger neighbor and got pulled out of alignment like a hat blown askew in the wind. Irregular galaxies can look like cosmic splatters or scribbles, but they're often bursting with new stars, full of energy, chaos, and potential. Some galaxies fall between categories too, spirals with big bulges, ellipticals with rings, and other hybrid forms. Galaxy classification, like everything in astronomy, can be as messy as the universe itself. But we still try to put them into boxes, mostly because that's how humans like to make sense of things, even the stars. And of course, a galaxy's shape isn't just about looks. It tells us something fundamental about its history. Spiral galaxies likely had a calmer upbringing, steady flows of gas, maybe a few small mergers, but nothing too traumatic. Elliptical galaxies probably saw more action, major collisions, repeated mergers, and a more tumultuous evolution. Irregulars? Well, they might just be young, unlucky, or both. What's fascinating is that even now, galaxies continue to change shape. Spirals can become ellipticals. Little galaxies can merge and form giants. Gravitational interactions tug on arms, twist cores, and scatter stars. Nothing in the universe is truly static, especially not something as dynamic as a galaxy. The Hubble Space Telescope has given us our clearest look at this cosmic diversity. With it, we've seen galaxies in all stages of life, from tiny proto-galaxies in the early universe to grand spirals and massive ellipticals much closer to home. We've watched galaxies collide, stretch, and tear, and then rebuild themselves in the aftermath. Every galaxy tells a story, and sometimes that story is written in its very shape. So the next time you see an image of a galaxy, a perfect spiral with blue arms, a glowing elliptical halo, or a lopsided clump of stars, know that you're looking at billions of years of history. Each one is a story of gravity and light, of stars born, aged, and gone, of gas clouds drifting, colliding, and becoming more than they were. Galaxies don't just shine, they remember. Let's come back home for a bit. We've been drifting through the vast universe, tracing the birth of stars and the swirling forms of galaxies. But now it's time to return to our own corner of the cosmos, a place we know intimately, not because we've seen it from the outside, though we've tried, but because it's where every sunrise, every sigh, every story has unfolded, the Milky Way. We live inside a galaxy called the Milky Way, and she's quite the hostess. From our spot within her, it's impossible to see the whole galaxy at once. It's a bit like trying to read the label on a bottle from inside the glass. What we do see, if we're lucky enough to be somewhere dark, away from city lights, is a glowing river of light stretched across the night sky. That shimmering band, part dust, part starshine, is our view across the galactic plane. We're looking edge on through billions of stars. The Milky Way is a spiral galaxy, and not a small one either. It stretches about 100,000 light years across and harbors somewhere between 100 and 400 billion stars. Why the wide range? Because it's really hard to count stars when you're nestled inside their midst, peering out through thick clouds of gas and dust. But the best estimates place us about a third of the way out from the center, in a minor spiral arm called Orion's Arm. Cosmic suburbs, not too close to the chaos, not too far from the action. The center of the Milky Way is a wild, energetic place. At its core lies a supermassive black hole called Sagittarius A, a gravitational heavyweight about 4 million times the mass of our Sun. It isn't the brightest object in the sky, it's not as voracious as some black holes at the hearts of other galaxies, but it anchors the whole spinning structure. Stars whirl around it in dizzying, intricate orbits, like moths to an invisible flame. How do we know it's there? Not because we can see it directly, but because of its influence on its surroundings. Imagine watching a crowd swirl around a person you can't see. Astronomers have tracked the paths of stars near the galactic center for years and found they move in tight, fast loops. Evidence of something incredibly massive, incredibly compact, and incredibly hungry lurking in the shadows. And don't worry, it's not coming for us. The black hole stays very busy in the galactic core. The Milky Way hasn't always looked like it does now. Like all galaxies, it has a long, eventful history, shaped by mergers and cosmic acquisitions. Over billions of years, smaller galaxies were drawn in, digested, and folded into the spiral. Remnants of these devoured galaxies still linger in the Milky Way's outer halo, orbiting on long, looping paths, ghosts from lost cosmic villages. And the process is still happening. Even as you listen, the Milky Way is gently pulling apart several smaller galaxies. The Sagittarius dwarf galaxy, for example, is being unraveled and absorbed, its stars tracing faint, ghostly loops through our galactic halo. It's not a violent process, not on human timescales anyway. It's more like watching a drop of ink slowly swirl into a pool of water. But the real drama is yet to come. The Milky Way is on a slow-motion collision course with our nearest large neighbor, the Andromeda Galaxy. Andromeda is about 2.5 million light-years away and is heading towards us at roughly 110 kilometers per second. That might sound terrifying, but we've got about 4 billion years before the big event. When it finally happens, it won't be the end of the world. In fact, the two galaxies will likely merge into a new, larger galaxy, possibly an elliptical. Astronomers have even suggested a name, Milkomeda, which, let's be honest, sounds more like a galactic dairy product, but let's roll with it. What's astonishing is how much we know about all this, considering we're observing from deep inside the galaxy itself. Thanks to radio telescopes, infrared observations, and a lot of clever math, we've managed to map out the spiral arms, trace populations of stars, and even simulate the birth and future of our galaxy. It's like piecing together a jigsaw puzzle from inside the box, only to discover the picture is far bigger and more complex than you imagined. And through it all, our sun just keeps orbiting. It takes about 225 million years for the sun to complete a single lap around the Milky Way's center. That means our solar system has only made about 20 trips since it first formed. For perspective, the last time we were in this part of the galaxy, dinosaurs were just starting to stomp around the Earth. Galactic years aren't measured in birthdays, but in epochs. So here we are, spinning quietly in one of the galaxy's spiral arms, a pale blue dot circling an ordinary yellow star, wrapped in the soft light of a billion suns. Every molecule in your body, every atom was forged in stars that lived and died long ago, possibly in galaxies that were later folded into our own. You are, quite literally, a chapter in the Milky Way's story, a moving, breathing fragment of galactic history. You're made of star stuff, listening to the echo of starlight. The galaxy isn't just out there. You carry it within you. If galaxies are the grand cities of the cosmos, what keeps them together? What laid their invisible foundations, kept their stars from drifting apart like dandelion seeds in the wind? Three unlikely architects have been quietly working since the beginning: gravity, dark matter, and black holes. They're not exactly a social bunch. None of them glows, sings, or gets invited to cosmic parties. But without them, the universe would be empty and formless. Let's start with gravity, the oldest, most familiar force around. Gravity is the great gatherer. It doesn't make a fuss, it just pulls. Always has, always will. In the early universe, as everything expanded outward from the Big Bang, gravity was the reason some things began to clump together. It took those faint ripples in the density of space, the tiniest wrinkles, and began to amplify them, drawing gas and dark matter together until stars and galaxies could form. Gravity is slow, patient, and never gives up. But here's the twist. Gravity, for all its importance, is actually the weakest of the four fundamental forces in physics. Drop a paperclip, and gravity pulls it to the floor. Hold a magnet above it, and suddenly the paperclip ignores gravity entirely. That tiny magnetic force wins over the whole Earth's pull. So why does gravity get to shape the cosmos? Because it always adds up. It never cancels itself out, like electric or magnetic forces can. The more mass you have, the more gravity you get. And in the emptiness of space, without friction or air resistance, gravity's quiet persistence becomes unstoppable. But even with gravity in play, there was a mystery. Something was missing. When astronomers measured how fast stars orbited in galaxies, they noticed something strange. Stars far from the center were moving way too fast, so fast, in fact, that according to the visible mass, they should have flown off into space, like glitter from a spinning wheel, but they didn't. They stayed put, loyal and orderly. This was a problem. Unless there was extra mass we couldn't see, a lot of extra mass. Enter dark matter, the invisible substance we can't see, touch, or smell, but one we're almost certain exists because its gravitational fingerprints are everywhere. Dark matter is one of the universe's strangest secrets. It doesn't interact with light, doesn't glow, reflect, or block it. That's why we call it dark. And yet, its gravitational effect is undeniable and everywhere. In fact, there's about 5 times more dark matter than normal matter in the cosmos. For every star or cloud of gas you see in a galaxy, there's a much larger, invisible halo of dark matter holding everything together. Imagine a galaxy as a glowing jellyfish swimming inside a giant invisible bubble. That bubble, the dark matter halo, is what keeps the jellyfish from drifting apart, no matter how fast it spins or how many collisions it survives. Without dark matter, galaxies as we know them couldn't exist. They probably wouldn't have formed in the first place. And if they had, the stars would have flown off in every direction. The beautiful spiral arms would have unraveled, and the universe would be a very empty, very boring place. But what is dark matter? That's still one of the biggest open questions in science. There are plenty of theories: exotic particles, supersymmetric partners, even ideas that involve extra dimensions or tweaks to the laws of gravity. But so far, none have been confirmed. Still, its effects are as real as wind on your face. You don't need to see the wind to know it's there, moving the trees and stirring the grass. Likewise, we see the shape of galaxies, the way they rotate, and the structure of the cosmic web. And we know something unseen is holding it all together. And as if galaxies weren't already full of secrets, There's a third member of this invisible trio: black holes. Not just any black holes, but supermassive black holes. These cosmic heavyweights sit at the centers of nearly every large galaxy, including our own. They range in size from millions to billions of times the mass of the Sun. And while they have a reputation for being destructive, they're more like galactic administrators: quiet, mysterious, and incredibly influential. For a long time, we thought supermassive black holes were just passengers, things that happen to form in the center of galaxies, with little real impact on their surroundings. But over the last few decades, we've realized they're more like co-authors of a galaxy story. Their growth appears to be deeply connected to the evolution of their host galaxy. When they feast, devouring gas and dust, they can release mind-boggling amounts of energy, sometimes more than the combined light of all the galaxy's stars. This energy isn't just for show. It can blow away the gas needed to form new stars, effectively halting star formation for millions of years. In other words, supermassive black holes don't just sit at the center of galaxies. They regulate growth, shape the fate of their hosts, and sometimes act as cosmic gardeners, pruning or fertilizing entire regions of space. This process is called feedback, and it's still an active area of research. But it's clear that supermassive black holes can influence their environment on absolutely colossal scales. Some shoot jets of plasma thousands of light years into space, sculpting the interstellar medium and altering the flow of material across the galaxy. It's a bit ironic. The darkest things in the universe, the ones that swallow light and defy our gaze, are also the ones that hold everything together. So to recap, dark matter, gravity, and black holes are the unsung architects of galaxies. They don't shine, they don't sparkle, but without them, there would be no cities of stars, no spiral arms, no places for planets or people. And here we are, orbiting a star in a spiral galaxy, nestled in a dark matter halo, circling a supermassive black hole we'll never meet. Every step you take, every breath you draw, happens in a universe held together by invisible hands. So the next time you gaze up at the stars, remember, the beauty you see is just half the story. The rest, the invisible scaffolding, the silent forces, the quiet gravity pulling it all together, is still there, not shining, not speaking, but always building. Galaxies might look serene in photos, graceful spirals, glowing halos, delicate dust lanes, but don't let that calm fool you. The universe is not a quiet place. Out there, galaxies are constantly moving, drifting, orbiting, pulled by gravity like dancers in a never-ending waltz. And sometimes those dancers get a little too close. Their arms entangle, their paths cross, and they collide, not with a bang, but with a slow, spectacular ballet that unfolds over hundreds of millions, even billions of years. Yes, galaxies crash into each other. But before you picture stars exploding and planets smashing like marbles, take a breath. The reality is more poetic. Despite their size, galaxies are mostly empty space. Stars are spaced so far apart that even in a full-blown galactic collision, the odds of two stars actually colliding are vanishingly small. It's like watching two fog banks pass through each other. Only the fog is made of stars, gas, dust, and dark matter, all swirling in gravitational fields. But while individual stars may avoid a direct hit, the galaxies themselves don't emerge unchanged. When two galaxies meet, their gravity pulls and stretches them, distorting their shapes into long, flowing trails of stars called tidal tails. These can reach hundreds of thousands of light years into space, glowing ribbons unraveling as the galaxies merge. Each is a trail of stars flung outward by the encounter. Gas clouds, on the other hand, aren't so lucky. When they collide, they do so with gusto, compressing, heating up, and often triggering a dramatic burst of star formation. These so-called starburst galaxies can produce stars at dozens or even hundreds of times their normal pace, a cosmic baby boom sparked by chaos. Some of the most beautiful and chaotic galaxies we've ever seen are caught mid-collision. The antennae galaxies, for example, two spirals in the process of merging, show long curling arms of stars and brilliant regions of new star birth. They're a snapshot of what happens when galaxies refuse to mind their personal space. And eventually, the two galaxies will settle into one. That final product? It usually isn't a spiral anymore. Spiral structures are delicate, too easy to disrupt. After a major merger, the result is usually a giant elliptical galaxy. The orderly orbits of stars are randomized. Much of the gas is used up or flung out, and the beautiful spiral arms are lost. That's how many of the universe's largest galaxies came to be. Not from peaceful growth, but from slow-motion crashes, like cities built by overlapping tectonic plates. But this isn't just ancient history. The Milky Way is not a passive observer. It's had and will have its own collisions. Right now, our galaxy is in the slow process of merging with several smaller dwarf galaxies. The Sagittarius dwarf galaxy is currently being torn apart and absorbed, its stars tracing ghostly arcs through the Milky Way's halo. Other small galaxies are on similar paths, being digested and folded into our own. And then there's Andromeda, our nearest large neighbor. The Andromeda galaxy is on a collision course with us, separated by 2.5 million light-years, but moving toward us at about 110 kilometers per second. That might sound fast, but in galactic terms, it's a slow, graceful approach. The collision won't happen for another 4 billion years or so, but when it does, the result will be spectacular. What will that future collision mean for us? Surprisingly, not as much as you might think, at least on the scale of our solar system. Remember, stars are so far apart that during even the grandest galactic mergers, the odds of two stars actually colliding are almost zero. Instead, what will really change is the sky itself. Over millions of years, Andromeda will grow larger and brighter, becoming an ever more dramatic sight. Eventually, the two galaxies will twist around each other, merge, and settle into a new shape, likely a massive elliptical galaxy. Astronomers have even picked out a nickname for this future cosmic mashup, Milkomeda. It may sound like a brand of space yogurt, but it's a real scientific proposal. And this isn't a one-off event. Even before the Milky Way and Andromeda begin their grand dance, smaller collisions are happening all the time. Dwarf galaxies are steadily being absorbed, their stars joining the great swirl of the Milky Way. All around the universe, galaxies and dense clusters interact, tugging at each other's shapes, stirring up gas, and sometimes colliding head-on. Each event leaves its mark, a distorted spiral here, a starburst of newborn suns there, a long streamer of stars, stretching into space like a galactic tail. What's fascinating is that these mergers aren't just destructive. In many cases, they're creative. Collisions can restart star formation, fuel supermassive black holes, and reshuffle the contents of galaxies in ways that lead to entirely new structures. It's a bit like pruning a tree or blending two colors of paint. You end up with something new, often more vibrant, sometimes more chaotic, but always a product of everything that came before. And in our ever-evolving universe, galactic collisions are the rule, not the exception. We might think of the cosmos as calm and unchanging, as if the stars have always been where they are, quietly shining in the night. But it's alive with movement. Galaxies are drifting, falling into one another, blending their stars, their light, and their stories. Even now, somewhere out there, two galaxies are beginning a dance that will take billions of years to finish. One day, they'll merge, not in a burst of violence, but in a long, slow embrace, and a new galaxy will be born, just as it always has been, just as it always will be. To gaze into space is to gaze into time. It's one of the most quietly astonishing facts about the universe. Every star you see in the night sky, every galaxy caught by a telescope, is not showing you how it looks now, but how it looked then. Light, for all its speed, still takes time to travel, and space is vast beyond imagining. Take our sun, for example. The warm light you feel on your face during a late afternoon walk left the sun's surface about 8 minutes ago. That sunlight is already 8 minutes old by the time it touches your skin. You never see the sun as it is, you see it as it was. Move a little farther, and the time delay grows. The light from Alpha Centauri, our nearest stellar neighbor, is over 4 years old by the time it reaches us. The glow of the Andromeda Galaxy, that's ancient light. It began its journey toward us more than 2.5 million years ago, long before the first humans, long before writing, long before the wheel. That gentle, ghostly shimmer in the sky is a memory, a whisper from a time so distant it predates everything we know. But we can go further. With the right tools, we can peer back billions of years, almost all the way to the beginning. The deeper we look, the further back in time we travel, peeling away the layers of cosmic history, one photon at a time. This is where telescopes become time machines. Take the Hubble Space Telescope, for instance. Launched in 1990, orbiting high above Earth, Hubble has shown us things no one imagined we'd ever see. One of its most famous achievements is the Hubble Deep Field. The idea was simple. Astronomers pointed Hubble at what seemed like an empty patch of sky, a region so small and dark it looked utterly blank. They let it stare for days. When the images came back, that nothingness was revealed to be packed with galaxies, thousands of them, each containing billions of stars, all crowded into a patch of sky smaller than a grain of sand held at arm's length. Some of those galaxies were more than 13 billion years old. We were looking back in time, almost to the moment when galaxies first began to form. That ancient light had traveled nearly the entire age of the universe just to reach us, crossing unimaginable distances, passing by uncountable wonders, finally landing on Hubble's mirror and leaving a faint but permanent trace. Now, we have an even more powerful time machine, the James Webb Space Telescope. Launched in 2021, Webb can see even deeper into the past, not just because it's bigger, though it is with a mirror over 6 meters wide, but because it sees in infrared. That's crucial. As the universe expands, light from distant galaxies is stretched out, shifted to longer and longer wavelengths, a phenomenon called redshift. The earliest galaxies now glow mostly in infrared. Hubble could catch a glimpse of that light, but Webb was built to revel in it. Already, Webb is showing us galaxies that existed just a few 100 million years after the Big Bang. Some are small, irregular, and chaotic, just what astronomers expected. Others are surprisingly mature, like seeing a sprawling metropolis where you'd expect only a cluster of huts. These discoveries are reshaping our understanding of how fast and how early galaxies formed, and may even force us to rewrite parts of cosmic history. And here's the most poetic part. The farther away a galaxy is, the younger it is in reality, but the older it appears to us, because we're seeing it as it was billions of years ago. You might think we're always looking into the past, and you'd be right, but in a way, that's the gift of astronomy. We can't rewind the universe, but we don't need to. It has already sent its memories to us, one photon at a time, and we're catching them, slowly, quietly, with glass, gold, and great patience. In a way, this is what science so often is, listening to the past with ever better ears. Of course, all this looking back has its limits. There's a wall in time we can't see beyond, a cosmic horizon. That barrier is the cosmic microwave background, the afterglow of the Big Bang itself. It's not that there's nothing before it, rather the universe was opaque until that moment. Before atoms formed, light simply couldn't travel freely. It was trapped, scattered endlessly, like fog in a dense forest. Only after the universe cooled enough for neutral atoms to form did light finally break free and begin its long journey to us. That's our horizon, the edge of visibility. Beyond it, everything is wrapped in mystery, and questions we're still struggling to answer. But what we can see is extraordinary. Every image from James Webb, every frame from Hubble, is a photograph of the past, a snapshot of a moment so distant it feels almost like a dream. But that light is real. It touched something, a star, a galaxy, a cloud of gas, billions of years ago, and now it touches you, here, as you listen in your own quiet corner of the world. So next time you look up at the night sky, remember, you're not just gazing out, you're gazing back, way one back. The stars are shining, but most are shining from a time when Earth was young, when there were no eyes to see, no names to give them, and yet their light still crossed the void to find you tonight. The universe doesn't just tell stories, it remembers them. We've journeyed far tonight, from the first whispers of matter to the sprawling spirals and glowing hearts of galaxies. We've watched the universe light up, organize, and evolve, but our story isn't over. The cosmos is still a work in progress. Galaxies are still forming, still merging, still reaching across the cosmic void. Because galaxies, like people, tend not to live alone. They gather. They form groups, clusters, and even superclusters, vast structures so enormous they challenge the imagination. Our own Milky Way is part of such a gathering, the local group. It's a relatively quiet cosmic neighborhood made up of more than 50 galaxies, most of them small, faint dwarfs, orbiting the larger members like cosmic satellites. The local group's biggest players are us, the Milky Way, and our neighbor, the Andromeda Galaxy. We're the twin giants of this little galactic suburb, slowly spiraling toward each other. We've already talked about our future merger, but for now, the two galaxies keep their distance, close enough to notice, far enough to avoid any awkward encounters. Surrounding us are smaller companions. Some, like the large and small Magellanic Clouds, are easy to spot from the southern hemisphere and are themselves in the process of being drawn into our spiral arms. Others, like the Draco Dwarf or Ursa Minor Dwarf, are more elusive, faint collections of stars barely holding on to their identities as they orbit through the Milky Way's dark matter halo. Groups like ours are common, but they're just the beginning. Zoom out and you find galaxy clusters, huge collections of hundreds or even thousands of galaxies bound together by gravity. The Virgo cluster, for example, sits just beyond our local group and is teeming with spirals, ellipticals, and every galactic oddball in between. In these environments, galaxies aren't politely distant. They crowd together, interact, and often collide. You can almost feel the tension, the gravitational tug-of-wars happening across millions of light years. And these clusters are themselves part of even grander structures, superclusters. Our cosmic address, in the largest sense, is in the Laniakea supercluster, a sprawling region over 500 million light-years across, containing about 100,000 galaxies. That's right, 100,000 galaxies, each with billions of stars, all drifting together through the universe, following the flow of gravity through a web we're only beginning to map. And even that is just a thread in the larger cosmic web, the true skeleton of the universe. Galaxies aren't sprinkled randomly through space. They form patterns, filaments, sheets, and nodes, like a vast cosmic foam stretched across a dark ocean. These structures, seated in the universe's earliest moments, have been shaped over billions of years by the subtle nudging of dark matter and the relentless pull of gravity. Between the filaments lie voids, enormous, silent regions where almost no galaxies are found. Some are tens of millions of light-years wide, dark and lonely, with only the occasional solitary galaxy drifting through, like a ship on a cosmic sea. It's in the contrast between the crowded clusters and the vast, empty voids that the modern universe's structure reveals itself. But not everything is racing ahead. Not everything is growing. There are signs that in some ways, The universe's grand dance is slowing, not in its motion, but in its creativity. Many galaxies, especially the big mature ellipticals, are no longer forming stars. They've used up or lost the gas needed for new stellar birth. Astronomers call them red and dead, not lifeless, but glowing with the dim light of aging stars, with no new generations to take their place. Even our own Milky Way is forming fewer stars than it once did. It's not finished, not by a long shot, but the era of frantic star birth is winding down. We're in a quieter, more reflective chapter of galactic life. And the universe itself? It's still expanding, but faster and faster, thanks to something we don't fully understand: dark energy. This mysterious force is pushing galaxies apart at accelerating speeds. Over the next few trillion years, it's possible that galaxies not gravitationally bound to us will simply vanish from view, their light stretched until it can never reach us. The universe will grow colder, quieter, and ever more isolated. But don't worry, we have time, a lot of time. For now, galaxies continue to interact, evolve, and surprise us. With telescopes like Hubble, James Webb, and the ones still to come, we're peering deeper into space and further back in time than ever before, catching the echoes of galactic birth, the ripples of collisions, the faint shimmer of newborn stars and galaxies so far away their light left before Earth even had oceans. Every night sky is filled with those echoes. Every glowing dot is a story. Some just beginning, some ended long ago, but all part of this vast, beautiful architecture. The visible universe is still painting itself, even now. Galaxies are no longer just mysteries. They're companions, teachers, reminders that even in a universe so enormous we can't hold it all in our minds. We belong to it, and it belongs to us. And now, after billions of years and billions of light years, we find ourselves at the quiet edge of our journey. We've drifted from the first whispers of matter to the grand spirals and glowing hearts of modern galaxies. We've watched the universe ignite, evolve, and organize itself. And now, as we settle into the present, it's clear. The story is far from over. The universe is still changing. Galaxies are still swirling, merging, and reaching for one another across the gulf of space. The great cosmic web is always in motion, always shifting, even as some parts slow down and others flare with new energy. It's a living tapestry, woven from the threads of light, gravity, and time. But let's pause for a moment and reflect on what this means for us, not just as curious minds, but as beings made of the very stuff that built galaxies. Think about it. Every atom in your body, every breath you take, is a product of stardust. The carbon in your cells, the calcium in your bones, the iron in your blood, all were forged in the heart of ancient stars. Those stars lived, shone, and died in galaxies that once collided, merged, and evolved, eventually giving rise to new generations of stars and, somewhere, to us. You are, quite literally, the universe becoming aware of itself. The night sky is a cosmic time machine, and every glance upward is a personal connection to our shared history. The light from distant galaxies is ancient, yes, but it's also intimate because it's part of the same story that led to you, right here, right now, listening and wondering. Perhaps that's why the night sky has always been so comforting, so quietly awe-inspiring. When we look up, something inside us settles. We find peace in the slow, patient unfolding of the cosmos, in the knowledge that the universe is still writing its story, and that we are written into its pages. Science, at its core, is an act of remembrance. We listen to the echoes of the past, read the patterns in the starlight, and use them to imagine what might come next. Every new discovery, every image from a telescope, every spectrum of a distant galaxy is like finding a new page in the universe's diary. Each one adds detail, color, and wonder to the story we share. And as our tools improve, our vision sharpens. With every new telescope, we peer deeper into space, further back in time. We're catching glimpses of the universe as it was when galaxies were young, when the first stars were born, when everything we now know was only beginning. We're learning that the cosmos is even more dynamic, more creative, and more surprising than we ever dreamed. But there's humility in this too. We're reminded that for all our knowledge, there are still mysteries beyond our reach. Questions about dark matter, dark energy, the birth of the very first stars. The universe keeps some of its secrets close. Some may be revealed in time. Others may remain forever just out of reach, inviting new generations to wonder and explore. And yet, even in our not knowing, there is comfort. The fact that the universe is bigger, older, and more mysterious than we can fully comprehend is not a reason for despair. It's a reason for awe. There is always more to discover, more to understand, more to marvel at. We are part of something vast, and that vastness is an invitation, not a boundary. So as you settle in, perhaps ready to drift off to sleep, know that you are resting beneath the same stars that shone on your ancestors, on the first humans, on the first creatures to look up and wonder. You are connected by curiosity, by memory, and by stardust to every corner of the universe. The galaxies continue their dance. The stars keep burning and fading. The cosmic story unfolds, and you are here, a witness to its wonder. Maybe that's all we need to know, that in a universe so immense, so patient, and so beautiful, each of us is both an observer and a participant, both a question and an answer, both a traveler and a home. So as your eyes grow heavy and your thoughts soften, let the stars keep watch, let the galaxies keep spinning, and let the science of the universe rock you gently toward dreams. There's a whole cosmos waiting for us, full of stories yet to be told, discoveries yet to be made, and mysteries yet to be unraveled. And I, for one, can't wait to explore it with you. But for now, let's rest. Let the night sky be your blanket, the quiet hum of the universe your lullaby. Good night, fellow traveler. You're home among the stars. We've covered a lot of cosmic ground together, from the first shimmer of hydrogen in a dark universe, through the birth and wild adolescence of galaxies, to the gentle swirl of our own Milky Way. But as we settle into this quiet chapter of our story, it's worth remembering that our understanding of the universe is still growing, still full of unfinished sentences and half-written pages. Take the mystery of galaxy evolution, for example. We know that galaxies form, merge, and change shape, but the details are astonishingly complex. Every discovery brings new questions. Why do some galaxies stop forming stars while others keep churning out new generations? What exactly triggers a galaxy-wide starburst, lighting up billions of suns at once? How do black holes and dark matter halos shape the destinies of these star cities? Some answers have come from the most unlikely places. Ancient star clusters in the outskirts of galaxies, for instance, act like time capsules. Their chemical fingerprints and orbital patterns reveal stories from the universe's early days. By measuring the light from these clusters, astronomers can reconstruct the merger history of a galaxy, like reading the rings of a tree to tell its age, or the scars on a landscape to learn its past. Meanwhile, new telescopes are revealing the universe as we've never seen it. The James Webb Space Telescope, with its sharp infrared eyes, is peering into dusty star nurseries and ancient galaxies with clarity Hubble could only dream of. Each new image is a puzzle piece, a glimpse of the universe when it was young, more chaotic, and full of surprises. Some galaxies appear far more mature than our theories predicted, challenging us to rethink how quickly complexity arises. And it's not just about looking back. we're also watching the universe change in real time. Supernovae, exploding stars, light up distant galaxies, briefly outshining all the stars around them. Gamma ray bursts flash for seconds, carrying the energy of billions of suns. Even on the scale of human lifetimes, the cosmos remains dynamic. Stars are born, die, and send ripples through the fabric of their galaxies. All of this is made possible by light. Light is our messenger, our time traveler, our silent storyteller. Whether it's the faint microwave hum from the dawn of time, the bright flash of a newborn star, or the gentle twinkle of a galaxy millions of light years away, every photon that reaches us carries a piece of the universe's memory. But the universe also speaks in other ways. Gravitational waves, ripples in space-time itself, are a brand new sense, only recently unlocked. In 2015, scientists detected the first gravitational waves produced by merging black holes over 1 billion light years away. Suddenly, we could listen to the cosmos in a way no one had before, catching the echoes of some of the most violent events in existence. With every new tool, our picture of the universe gets richer. We're now mapping the cosmic web with unprecedented precision, tracing the patterns of dark matter through the subtle bending of light, a phenomenon called gravitational lensing. Even the smallest distortions help us map the invisible skeleton that holds galaxies and clusters in place. And as we look forward, we realize we're just at the beginning. New missions, like the Vera Rubin Observatory, set to scan the entire sky every few nights, promise to uncover even more cosmic wonders, from roaming black holes to the faintest, most distant galaxies ever seen. As we gather more data, we'll learn not just about the universe's past, but about its future, the fate of galaxies, the destiny of stars, and maybe even the ultimate story of space and time itself. Yet for all this, our place in the story remains both humbling and profound. Here we are, orbiting an ordinary star in the outskirts of a spiral galaxy, on a planet that's neither the biggest nor the smallest, in a solar system spinning quietly through space. Our lives are brief flickers compared to the ages of galaxies, and yet we're able to look out, to wonder, and to understand. You are a part of that story, an observer, a thinker, a questioner. Every time you look up at the night sky, you're participating in an ancient tradition, the search for meaning in the stars. Every discovery you hear about, every question you ask, brings you a little closer to the universe's heart. And maybe that's the greatest gift of all. The universe is vast, mysterious, and sometimes overwhelming. But it is also connected, patient, and full of stories waiting for curious minds to find them. In the end, science isn't just about facts and figures. It's about wonder, connection, and the simple, profound act of paying attention. So as you drift towards sleep tonight, know that the universe keeps spinning, galaxies keep colliding, and somewhere far away, the first light of a newborn star is just now beginning its long journey toward Earth. Maybe someday that light will find you, reminding you that you too are made of stars, woven into the fabric of a cosmos that is both ancient and ever new. Good night, fellow traveler, and thank you for wandering the universe with me. And so, as we reach the final stretch of our cosmic journey, let's pause to appreciate where we are, not just in space, but in time, in understanding, and in possibility. We live in an era of unthinkable discovery. Just a few generations ago, the Milky Way was the whole universe. Now we know it's one among trillions, each a city of stars, each with its own history, mysteries, and future. In the last century, we've gone from blurry telescopic smudges to crisp portraits of colliding galaxies, glittering star clusters, and the faint red-shifted glow of the first cosmic dawn. And the pace of discovery is only accelerating. New observatories, on Earth and in space, will soon let us map billions of galaxies, watch supernovae in real time, and search for the faintest fingerprints of life on planets far beyond our solar system. The universe is opening itself to us in ways our ancestors could never have dreamed. But perhaps the most extraordinary part of this story is how it connects us, not just to the stars, but to each other. We are a species defined by curiosity, by the longing to understand, by the urge to look up and ask, what's out there? Every discovery, every new question is shared by scientists and stargazers, by students and storytellers, by anyone who's ever felt the pull of the unknown. The light from distant galaxies is, in a sense, a kind of cosmic inheritance. It's traveled for billions of years to reach us, surviving the vast emptiness, carrying with it the record of everything it's seen. And when we catch it, when we measure it, study it, or simply marvel at it, we become part of that story. We are the latest recipients of the universe's ancient messages and the first to send our own signals out into the dark. Because now, for the first time in history, Earth is not just listening, we are speaking, broadcasting radio waves, mapping the sky, sending spacecraft to the planets, even launching probes like Voyager and New Horizons into the interstellar night. Our presence, our questions, our hopes, they are now part of the galactic conversation. And who knows what will come next? Perhaps someday we'll receive an answer, a signal from another world, another intelligence, another way of being in this cosmos. Or perhaps we'll simply keep searching, keep learning, keep growing, finding joy in the journey itself. One thing is certain, the universe is not finished. Its story is still being written in the light of newborn stars, in the dark between galaxies, and in the minds and hearts of those who wonder. Every discovery is an invitation for new explorers, new ideas, new dreams. So the next time you stand beneath the stars, remember, you are not just looking at the past. You are standing at the frontier of everything to come. The galaxies above are not distant and different things. They are kin, ancestors, neighbors, and reminders of what we share. Their light calls us to curiosity, to humility, and to hope. In the end, the greatest lesson of the galaxies may be this: we belong to the universe, and the universe belongs to us. We are made of its dust, shaped by its forces, and inspired by its endless beauty. Our small blue world is precious not in spite of its place in the cosmos, but because of it. We are a way for the universe to know itself, to celebrate its own existence, to dream beyond the limits of what has come before. So close your eyes, breathe deep, and let the stars watch over you. The galaxies are still spinning, the universe is still singing, and you are part of that song. Good night, and may your dreams be full of wonder.